Hi guys, this is a quick video to kind of help you out with the 5.3 application. And so 5.3 is about proving triangles congruent. And in this first page, you're basically making sure that you correspond the sides appropriate, or the points appropriately. So like for triangle OGD, it would be congruent to, so since OG is it has three tick marks, it would be like FR. So it'd be triangle FRC. So you'd write FRC here. Okay, so the first part is pretty standard. Based off of watching the video, you should be able to do the first part. In this application, the second part of the application is a little bit different. Here, we're going to be discovering other ways to prove triangles congruence. So our objective is to discover which three elements, whether it's sides or angles or a combination of the two groupings, we can use to prove triangles congruent. So in the video and online quiz, we had to prove that all 6 elements of a triangle were congruent. We needed to prove that 3 angles and 3 sides were congruent to prove that the triangles are congruent. And we also looked that we can transform one of them to overlap the other. This application will explore what shortcuts may be possible when only knowing 3 parts of each triangle are congruent. We will investigate each trio to prove congruency and which trios do not give sufficient information. So you need to go to the link that is on my webpage. Basically, if you go to 5.3 application, you can get to this document, but next to it, highlighted in yellow, is the website that you need to go to that has this link. Okay. So when you go to my when you go to the link, you will get to this page. And so you are going to construct triangles. So to construct a triangle, I'm just reading from the directions. Move the elements of the triangle so the points labeled with the same letters touch. So the first triangle we're going to end up doing is going to have 3 sides. Okay, so how you turn the sides is by clicking down on the points. And to move the sides, you click on the center part. So like I would want to make sure that this B lines up with that B. Okay, so I'm going to have to do some maneuvering like so. Then I'm going to want to make sure that this A lines up with that A, and that this C lines up with that C. So I'm going to have to do ta-da. Okay? So click and drag a dot to move the elements to a new location. Click and drag a sides endpoint or angles arrow to rotate the element. So let's say we had an angle. So to move angles, you can just move them like this, but we still, like you just move them around like this. But we still want to get it over another point, and then you click the ends of the angle to twist it. Okay. To help place elements, points marked with the same letter snap together. So did you see how, like here, there's 2 B's, but when I get close enough, they snap together. When angles snap, the rays are extended to the edge of the work area. When you create a closed triangle, the points merge and the center is filled. So like I did before, the points were merged. So quickly, if I do this, they snap together, and then see it merges. Okay, so now those were just some examples. Let's do SSS together. So in the top right, choose all 3 sides, AB, BC, and AC. I didn't mean to write CD, AC. So we have these 3 sides. And then use the congruent elements to make another triangle. So first, before we use congruent elements to make another triangle, let's make a triangle here. So I'm going to move this B to work. and then move the C. So close. Oh, there we go. Okay. So now use the congruent elements to make another triangle. See, number 2, use the congruent elements to make another triangle. So these side lengths are exactly the same as the side lengths over here as well. So I'm going to try to make another triangle. T. Let's put E together and try to get these to connect. So close. There we go. So are these triangles congruent? How do you know? So this one, I answered for you. I know these triangles are congruent because I rotated and translated one triangle. So I can move this triangle, oh, but I need to flip it. Maybe some more. See, I can rotate it like this. So I rotated it and translated it. And I see that these two triangles perfectly overlap each other. Okay? So because I know that these triangles are congruent because I rotated and translated one triangle so that it overlapped the other triangle. Is it possible to make a triangle that is not congruent? See on the bottom, it says, are these triangles congruent? We can say yes. Correct. These triangles are congruent. Is it possible to make a triangle that is not congruent to ABC? So now, try to make a triangle that's not congruent to triangle ABC. So that's locked in. I have this U, I have this D, I'm gonna lock D in. So the only way that I can put U is by putting these together. There's no other place that will work. These triangles are congruent. So I can try again, but every single time that I try, it's not going to work. All the triangles are going to be congruent. So I would say, I would come back to here and say, no, these triangles are not congruent. We can only make congruent triangles. So what statement can you say if you find two triangles that have congruent side, side, side? So you can think of this kind of as a theorem. If you find two triangles that have congruent side, 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 then what? We know that the triangles are congruent. So all we need to have are 3 sides to make sure that the triangle is congruent. Now you're going to continue this process with SSA, SAS, ASS, SAA, AAS, and ASA and AAA. You'll see that some of these are basically the same things twice. And then finally, you're going to summarize which one of these work and which one of them don't. Some of them do, some of them don't. All right, that's all. Have a good one. Bye-bye.